Okay, good morning, students. In this lecture, we are going to start with the sixth chapter, that is process construction material. So these are nothing but the advanced material in which some processed, or we can say these are nothing but the man-made, artificial, advanced materials. So these are not naturally available. So these are processed, just like a fly ash, then blast furnace, like these are the processed material. These materials are undergone through some processings, and from which these are obtained. So let me start with the introduction. What is process construction materials? So here it is, the introduction. Due to the great boom in construction industries, there is growing demand of traditional building materials as well as some processed or artificial construction materials. So over the period of time, there is arise a shortage of building material, that is the natural construction materials are now shortage, having a shortage. That's why this leads to the formation of new construction material or the innovative, cost effective, sustainable and more eco-friendly materials. Some of the common agro-industrial waste useful as a building material, just I said, the fly ash or rice husk, bag ash, then core fiber, straw, coconut, then areca nuts, tree trunks, coconut leaves, fly ash, blast furnace slag, then granite, marbles, the polishing materials or the construction waste, sawdust, plastic waste. So these are the some of the examples. The are called as a process construction materials on which some processing done, and they can reused, and this productivity will change uh, the quality of the environment also, because if we are throwing the baggage or sawdust or rice husk, then that is a wastage and that also harmful to the soil, that are reasons to the degradation of the soil or pollution of the soil, water, river. So that materials which are impact over or badly impacted over the environment are reused, recycled and used for the construction, and that is beneficial, that increases the strength parameter, durability. Some of them are used as an uh, just like additives. Okay, so that's why we can give up a more convenient uh, replacement over the natural material. So let me start with the first material, that is a fly ash and its uses. Fly ash is one of the residue generated in the combustion and compromises the fine particle that rises with the flue gases. It is ash produced during the combustion of the coal. Then, what are the properties? Here it is a images showing the fly ash which are stuck on a ground surfaces, and if it is filtered along with the water, rainwater, into the ground surfaces, that will be uh, harmful to the environment, and that's why that can be reutilized for the construction of the fly ash bricks. That bricks are lightweight and can be utilized for the construction of partition walls. In some malls also we observe these fly ash bricks can be utilized one. In paver block also fly ash can be utilized, and this fly ash increase the property of binding. Also, it also gives a good strength to the concrete block. So what are the properties? Fly ash contains silicon dioxide, then aluminum dioxide, ferrous trioxide, and calcium oxide. Some toxic elements such as arsenic, boron, manganese, and mercury. The fly ash together with the bottom ash is a non-hazardous material. The fly ash particles are spherical in shape, whose size ranges from zero point 0.5 micron to 300 microns. So that's why it can be a good filler material. It is heterogeneous material. So what are the uses of the fly ash? The burning of harder, older anthracite and bituminous coal produces the class of fly ash. This fly ash is pozzolanic in a nature, containing less than 20% of lime. Hence, together with the Portland cement, weak lime and hydrated lime and the water produces the cementitious compounds. In addition of water, glass to it. The class F fly ash can form the geopolymers, which is a good replacement. So it forms a geopolymer which gives a very good properties to the concrete, as in previous chapter we learned about the geopolymers. So then class C fly ash, this is for the class A fly ash. The class C fly ash, it produced from burning of the younger ignite or subbituminous coal in presence of water. It hardens and gains the strength over the time. It is used for making the fly ash bricks, then pavers as it in commercial markets. Then other uses are, it is used in concrete production as a substitute to the Portland cement. Then it is used for embankment and road construction. It is used in production of the grout and flowable fill for the crack filler in the building. Then it is used for the waste stabilization and solidification. It is used in cement clinker production as a substitute to the clay. So it is a great replacement for the Portland cement and the sand, and as well as for the clay. It is used for the land reclamation. Then it is used for the stabilization of the soft soil. It is used for the road sub-base construction. It is used as a substitute for the aggregate in brick production. Then it is used in a mineral filler in a asphaltic concrete. It is used for the production of roller compaction concrete, and it is used in a geopolymers. So these are the huge uses of the fly ash that can be a great replacement for the cement, sand, aggregate, then clay soil. So that's why it is widely used for the production of the cement also. Then blast furnace slag. The blast furnace slag is a non-metallic byproduct produced in the process of iron making in the blast furnace. Properties, it is mildly alkaline, having a pH value ranges from 8 to 10. It contains a small amount of sulfur, but it does not possess a corrosion risk to the steel in a piling or in a street embedded in a concrete made with the blast furnace slag. So this property makes him to replace some of the materials like aggregate, sand. Then these are also used for the concrete production. It is used also, it is used in also paver block making or the concrete block making. Then what are the classification based on granulated FB, sorry, BF slag and air cooled blast furnace slag. That is BF means blast furnace slag. So first one, that is a granulated blast furnace slag. It is a glassy granular material that varies from coarse, then popcorn like tribal structure greater than 4.75 mm size in a diameter to the dense sand size grains passing through the 4.75 mm sieve. When crushed to very fine cement size particles, ground GGBS, that is ground granulated blast furnace slag, has a cementitious process which makes it suitable replacement to the Portland cement. So these also having a good properties, because of that it can be utilized for the manufacturing of the cement. Then air cooled blast furnace slag, when the liquid slag is poured into the bed and slowly cooled under the ambient conditions, a crystalline structure is formed and hard lump slag is produced, which can be subsequently crushed. The crushed air cooled blast furnace slag is angular, roughly cubical, having the texture ranging from the rough porous to the glassy surfaces. The water absorption is very high. Then weight density is around 1940 kg per meter cube. Due to its good abrasion resistance, good soundness characteristics, and high bearing strain, it is used as an aggregate material. So as I said, it is good replacement over the cement, also over the sand and the aggregates. It has a porous structure, hence blast furnace like aggregate have a low thermal conductivity than the conventional one, and it is a high, having a very high insulating value. So it makes it desirable. What are the uses? Blast furnace slag is used in making an aggregates, having a application is a granular base embankment, engineered fill, and in highway and hot mix asphalt part. Though it is used in concrete aggregate in a construction bridges. Then it is used in a concrete masonry due to its desirable properties such as a lightweight and high fire resistance. Then it is also used as an aggregate with the asphalt for construction of dam-proof cores and waterproofing cores. Then it is used as a insulation in a mineral wool roof aggregates ECG. In railroad, it is used as a ballast. So these are the uses. The next, that is a granite polishing waste. So this is the next material which is utilized. In marble and granite industries, raw stone block is cut into the tiles or the slabs of various thicknesses or various shape and size. Then whatever remaining parts, that is a cut shapes or the cut sides, are called as a granite polishing waste. Then the water is showered on a blade while the stone blocks are cut into the sheets. Cool the blades and absorbs the dust of produced during the cutting operation. So the granite polishing waste is nothing but the waste produced during the cutting of desired shapes and size of the blocks. Then that cutting material is called as a granite polishing waste. The granite powder so obtained while cutting the granite slabs can be make the uh, partial sand replacement, as a test shows the it has a mechanical properties such as a compressive strength, split tensile and modulus of elasticity. There is granite powder when replaces the sand, the manufacturer concrete improves the strength and durability of the concrete. Then granite is a common and widely occurring type of igneous rock. It has a medium to coarse grain texture. They are used in different forms such as a granite powder, aggregate, granite chips, granite sand, etc. Then marble polishing waste. This is also same like a granite polishing waste. The some marbles while cutting they form some powder that also utilized for the replacement of the sand or the aggregate. So this also having a good uh, compressive strength. Okay, not as much like aggregate, but it is a partial replacement. The next material, that is agro waste material. The waste material produced from the agriculture byproducts such as green coconut shell, sugarcane bagasse, then straws, rice husk, then coconut fibers, coconut and areca nut, tree trunk, coconut leaves are some of the material which are produced during the agricultural activities. So the coconut shell bagasse or the empty cement bags are used for making the particle boards, then covered with thin sheets of wood, then veneer or waterproof laminates. These panels have improved the mechanical, thermal, and acoustic aesthetic properties, hence can be used for the construction of furniture and packaging industries. Then rice husk or the rice hull uh, is a natural hard coating provided by the nature for rice grain to protect it during the growing. So it having a following properties. First, it is difficult to burn, and it hence it is a property makes it good insulating material or fireproof building material. Then it is used as an excellent thermal insulating material. Then rice husk is highly resistant to the moisture penetration and fungal decomposition. The rice husk has a high silica content. Then it is have a low bulk density, and it is have high average calorific values. And because of that, it can be used as a rice husk is a good insulating material. Then it is used as a renewable energy source. Then it when it burns, the ash has excellent pozzolanic property and hence can be used for alternative in the cement concrete. Then it is used as a manufacturer of bricks. Then it is used as a fuel in a boiler and for a power generation. So due to this property, rice husk is now used for the cement construction also. So remaining part will be discussed later on. So here it is the images shows the rice husk. You can thoroughly see this. These are the images of rice husk. So remaining part we will discuss later on. Thank you.